Hello all, welcome to this module on repetition structures. In this module, we'll talk about two main types of repetition structures known as while and for loop in Python. Conceptually, they're also known as condition controlled or indefinite loops. This is to refer to while loop, and count controlled or definite loops for for loops. Okay, and we'll talk about why that is the case in a few moments. And later on, when we are using for loop, we'll also introduce something that we call a range function and see how we can use this function to use for loop effectively. Okay. As I mentioned before, in the beginning, we talked about executing the programming statements from top to bottom sequentially. And then we introduced decision structures. This is the if, elif, else structure to basically introduce conditions to change the order in which these programming statements are executed. So it complicates the execution structure slightly. Now, repetition structures allows us to introduce additional complexity to the way we write programs so that we can solve more meaningful problems. Okay, and if you really think about it, like in the past, we've solved this example of salary calculation. And we did this with the assumption that we're going to be calculating the salary for one employee, right? But what if the salary needs to be calculated for multiple employees, right? In this case, we don't want to be writing this code again and again and again. Rather, we would use this repetition structure, either the while loop or the for loop, to repeat the same piece of code that calculates salary multiple times. Okay? And as I mentioned before, together with decision structures, repetition structures help programmers write more sophisticated and complex programs. Okay? So first, what I'd like to do is talk about the while loop or condition controlled loop. Okay, so let's spend some time talking about this before we move on to the for loop. Okay, and if you actually look at the structure of the while loop, right, you can see that it's very similar to the if else condition, right? So what happens is here you have a block of code that executes when this condition is true. The difference between this and the if condition is that this block of code will keep executing as long as this condition is true, right? And as soon as this condition becomes false, then you exit the loop. Okay, and in a few moments, you're going to see an actual example to see how this looks syntactically in Python. But I would like you to pause for a few seconds and think about the implications of what we just talked about, right? I just mentioned that for a while loop, this conditional block, lines of programming statements, block is going to keep getting executed as long as this condition is true. So again, this basically means that you need to set up the condition. And usually this condition involves at least one variable. So which basically means that you need to have code, programming code before this, right? That kind of tells you what that variable value might be, right? And then you use the variable in a condition, right? And then the block of code gets executed as long as the condition is true. And as I mentioned, once the condition becomes false, then you quit the loop, which basically indicates to you somewhere here that you need to have something in here that changes the condition from true to false. Because if it does not change, then this is going to keep executing again and again and again. That's, again, another reason why this is called an indefinite loop, right? Because it's going to keep getting executed. This block of code is going to keep getting executed as long as this condition is true. And so you need to have something in the block of code that changes this condition from true to false. And in Python parlance, so the loop, each time the loop runs, we call it an iteration. So now let's just think about an example and see how a while loop might look like. You can see that, I'm basically giving you the code we had used before in a previous class, right? This is basically approving or denying credit for consumers based on a couple of criteria. And the example we looked at before, that's a salary criteria, right? Salary criterion and the experience criterion. And we will approve credit only if both conditions are satisfied. And I can also see that basically approving or denying credit for one consumer, this is the setup we used. This is going to execute once and that's it. right? Where I enter the salary, I enter the number of years of experience, and then based on the values of these two variables, right, salary and experience, I'm going to approve or deny consumer credit. So far, so good. It's a conditional structure, right? If this is true, this block of code is going to get executed. If it happens to be false, then this will be ignored, and instead, this line will be executed. All right. Now, what if you want to write a program that does this? You're happy with the core logic of this program, but you want to do this for multiple consumers. Okay. So I want you to think about how you would use this, right? The repetition structure, this in this case specifically condition control loop, to solve this problem. Again, remember that I'm happy with this logic. I don't want to change this. This is perfect. This works well. All I want to do is now, instead of doing this for one person, I want to do this for multiple consumers. When you're setting up this while loop, think about, ask the end user to type in yes or no. Right? Do you have another consumer to process? If the end user types in yes, then you run this code. And if the end user says no, I don't have any more consumers to check, then you don't execute this code. Right? So in essence, this core logic, right, becomes part of the conditional block here. So hopefully you can see that, right? So now my question to you is that you have this core logic that's going to go into the conditional block. So what else do you need to do to complete the program so that I can do this for multiple consumers? So I want you to pause the video here. Think about how you make this program work for multiple consumers. Okay, think about that. And again, you don't have to think about the syntax necessarily. Think about the logic. Think about what needs to be here before this code. Okay, and again, remember that I'm saying that this has to be the part of the conditional block. So I want you to think about what needs to be here, right, before this block can be used inside that condition. Okay, pause the video and come back once you spend some time thinking about it. All right, so what you see here is, again, the central logic, right, hasn't changed. It's right there. But what I've done is that I've added two superfluous print statements. I mean, they're not that important. I'm just adding it for, making it look neat when we run the code. All right. What else do I need? As I mentioned, I need a condition for the while loop, right? What is my condition? I need to check with the end user. Do you have more consumers to process? So what I did here is basically think up a variable. I call this loop more, and I'm asking the end user, hey, do you have to compute someone's credit, a consumer's credit? Type yes or no, right? So again, I'm using an input statement, and the user is going to type in yes or no. And so what I am doing here is that I assign that to a variable name, and in the while loop, again, remember that I'm using a comparison operator, which means not a single equal to sign, which is an assignment statement, but two equal to signs. I'm comparing the value of loop more, and I'm checking to see, hey, is this the same as yes? And if the user typed in yes, so then because this evaluates to true, this conditional block will be executed. This is the core logic, right? As I mentioned, inside this conditional block, I need to have something that breaks the loop, right? Because if I don't have anything else, it's going to keep going back, and it's always going to be yes. So this loop will run indefinitely, expecting the user to type in annual salary and years of experience again and again and again. You don't want that. So what you do need is something that could change this condition from true to false. So what I've done here is pretty simple. I'm basically taking this input here, right? Same variable, same input statement. I'm just adding this here because at the end of this core logic, I'm giving the end user an option. Every time I'm asking the end user, hey, do you have more? And if the user types in yes, then the condition is true. Do it one more time. The user types in yes again, do it another time. So third iteration. Again, this is an iteration. You go through iterations. Fourth iteration, fifth iteration. And as soon as the user decides the user does not have more, the user hopefully will type in no. Then you go up here, it's not yes. So the condition is false, and the program, and go to the main line logic, go to the main logic. Again, if you go scroll up here, it'll terminate this conditional block, right? Come back to the next statement that's outside this conditional block. Okay. And so the next statement that's outside this block, again, the block is indicated by this indentation. Again, remember that I mentioned for Python, the indentation is very important. And in this example, this is a conditional structure with this indentation here, which itself is nested within a while loop, a repetition structure. That's got one indentation here, one tab space here. Okay. So again, when you're writing programs, you will have to think about whether that program requires the repetition structure, whether that program requires a conditional structure, how many of those do you need, and how do they fit together. Okay, so let's see how this works. I'm just going to run this code quickly, right? I'm going to press enter. So if I type in capital Y, case sensitive, so if I type in capital YES, unfortunately, it's going to say, it's going to check for, is it YES, all lowercase? It's not all lowercase. So it's going to terminate the loop. So it did not even run once. So what you want to do is make sure that you use the right case. Just follow what's there, all in small case, YES, right? Now it's comparing the value of loop more. And because it's yes, right, its condition is evaluated to true, and it's getting inside that conditional block. And now it's similar to what we did in the previous module. So I'm going to compute a salary here. I'm going to type in 20,000. Number of years is 3. Unfortunately, 20,000 does not meet the threshold. So one of the condition is false. It has to be more than 40,000. So inside this conditional block, right, I have another condition that's evaluating whether the consumer has to get credit or not. And that's going to be denied because this is not more than 40,000. So this block will not be executed. Instead, because the condition is false, it's going to skip to the else part, and it's going to say print the consumer is denied. Okay, and then it's going to print this line. Just this is more for aesthetic purposes, and then it's going to ask the end user, do you want to compute more values? Okay, so let's do that. I'm going to press 3. It's going to say consumer credit is denied. It's going to ask, do you have more? If I say yes, I'm going to go through the exact same thing again and again and again, as long as I keep saying yes, all lowercase, right? And when I'm done, I have no more. I can type in no, small case, NO, then it's going to exit the loop. And as you remember, I don't have to type in no. If I type in a letter 1, 2, 3, 4, doesn't matter, 1, 2, 3. It's basically loop mode's value is 1, 2, 3, enclosed in string. It's a string value. It's definitely not YES, yes. So this still is similar to you typing in no. So the end user has to be careful. They have to make sure that they type in this exact value for the condition to be true. But for the condition to be false, it can be anything other than yes. That's going to be false. So in this case, if I press 1, 2, 3, intentionally or unintentionally, it's going to exit because I'm not saying yes. It's just going to assume that if it's not YES, all lowercase, it's a no. Then my processing is done. So hopefully this is clear. This is your while loop, okay? Now what I would like you to do is write a program using a while loop to print the first 5 positive integers, and they would be 1, 2, 3, 4, 5. So the loop presumably runs 5 times, and each time the loop runs, it's going to print the value 1, the value 2, the value 3, the value 4, and the value 5. Okay. So can you think about how such a program would look like? So again, pause the video, think about what you would need to do. Again, go back to this template here, right? So I'm saying print something here. So this has to be a print statement here somewhere in the conditional code. So it's going to run 5 times, 5 iterations. Each time it runs, it's going to print 1, 2, 3, 4, and 5. Right? So you need to set up a condition so that this runs 5 times and the loop is terminated. So now think about how can you set up this condition? What do you need to do to set up a condition to make this loop run 5 times? Okay, pause the video, think about it briefly, and then come back. Okay. So now one way to do this is that I need to set up a condition, right? That's basically, I'm setting up a condition using a variable called I, and obviously program doesn't know what I is. It's a variable name. So I need to assign this a value. Just like in the past, for loop more, you assigned a value yes or no. Here, instead of asking the end user, I know that I need to run this loop 5 times because that's what the program is asking. So I'm going to basically say I'm going to initialize a variable, right? A starter variable, I equal to 1. And then my condition is going to be as long as i's value is less than or equal to 5, print I. So the first time the loop runs, it's going to print 1. Right? But if I don't have anything else, then this is going to run indefinitely. And so that's where that other item I mentioned, where you have to have something inside that conditional block to change the condition. And here, what I am doing is I'm taking the variable I and I'm incrementing it by 1. So when I increment it, now i's value is changed from 1 to 2. I go back to the beginning, checking I value is 2 now. Is 2 less than or equal to 5? Yes. So print I. I is 2. So it's going to print 2. I'm incrementing again by 1. I's value is 3. Go back, check the condition. 3 less than or equal to 5? Yes. So print 3. Now I is 4. Is 4 less than or equal to 5? Yes. So print 4. I is 5. Go back. Is I less than or equal to 5? Yeah, 5 is equal to 5. So print 5. And now increment by 1. I is 6. So when I is 6, now suddenly 6 is not less than or equal to 5. 6 is more than 5. So this condition is now suddenly become false. So I'm going to exit this block of code, conditional block, and I'm going to come out. The mainline logic, and I'm printing it. And by the way, when I say mainline logic, I basically mean I'm going to come out of the loop and I'm going to continue execution after that block of code, which is indicated by this intended spaces here. Okay. So let's see if that worked, right? So I'm going to run this code and you can see that it ran 5 times. Each time it took the value 1, 2, 3, 4, and 5. And then when it became 6, it exited and it prints instead this. Okay. And again, this last print statement is there for pedagogical value, just to show that it exited the loop and then it's printing at the very end. Okay. Just to make this even more clear, and I want you to think about this, I have another piece of code that shows you the value of not only I, but also the value of this condition. So this, I'm printing this explicitly. Think about what data type do you think it is, right? I'm basically taking this, right? This is the Boolean expression. I'm basically printing value of the Boolean expression. So it's going to be either true or false, right? So now we can explicitly see the value of I and the value of the Boolean condition. Okay. And then once you finish the loop, I'm also printing the value of I and then the value of this condition again. So you can see what actually happens as this runs. Okay. So I'm showing everything explicitly. Obviously for the exam, you don't need to show me all of this explicitly, but I'm just showing this here for pedagogical purposes. Okay. Now you can see again, it's similar to before. 1, 2, 3, 4, 5, and you can see that every time the loop inside ran, the condition was always true. And then as soon as the I became 6, right, the condition is not true anymore, it was false. So it exited the loop, it printed the statement, and then it's printing the value of I. And remember that I's value now is 6 because I incremented by 1 so that when it went up, the condition was false. So I is 6, the condition is false. So you can see explicitly what happened inside the loop and then the value of I and the condition after the final iteration. Okay, so hopefully this makes it a bit clear for you, how the while loop works, right? Sometimes you set up a condition like this, you ask the end user to decide, right? Other times you decide for yourself what this variable is going to be. Like I'm setting up a condition using a variable I. Instead of asking the end user, the logic, the program here demands that you figure out what should be the appropriate initial value. If it's, is it 0? Is it 1? Is it 2? Right? And here's a question for you. If you started the value with I equal to 0, what do you need to change here to get the same output? All right. At this point in time, remember that you're using Jupyter Notebook, right? So, and you're using multiple cells, and sometimes you're using the same variables. So these variables have a value, and at this point in time, I has a value 6. Okay. And so it's always good to check what's there in the main memory of your computer, right? When you're running this Python program. As I mentioned earlier, I can use this shortcut called WHOS, W-H-O-S, right? Jupyter Magic function. So I'm going to run this, and you can see here that in the last several minutes, I ran some code cells. So I have this variable experience, loop more, salary from one of the previous problems. And then from the last problem, I also have a variable name I. So they all have different values. So these are the variable names and values that are still floating around. So if I go to the next cell here and I say print I, it's going to carry over. It's going to print 6. At some point in time when you're reusing the same notebook for multiple problems, it's always a good idea to periodically reset. And what do I mean by that? You run this code. It's basically saying, hey, once you reset, all of these things will disappear. Do you want to proceed? I'm going to say yes. Again, why? Right? It's done. So let's see if it worked. I'm going to go back to this and I'm going to see what happened. And you can see here that the interactive namespace is empty. Those variables are all cleared out. So I'm going to delete this. So I'm back to where I started. Now, I have a variation of the same problem that I have here. Write a program to print the first 5 positive integers. This program on its own is of limited use. So a question I might ask is like something like this. I could say write a program to print the first n positive integers. And think about what needs to change if instead of 5, right? Instead of 5 positive integers, I want n positive integers. And the user is giving me the value of n. Okay, so pause the video if you need some more time to think about it, and then come back and take a look at the solution. All right. So what needs to change is instead of 5, you need to have n here. That's all. So where is the n coming from? Obviously, the user is supplying the n. And so the user is saying 5, 6, 7, whatever it is. Otherwise, the logic is exactly the same, right? The only change I made was instead of 5, I replaced it with n. And then I'm asking the end user for the value of n. Okay. Again, I'm going to ask you to check this on your own, run the code cell, change the value of n, and see how the program runs. Okay. And then I wanted to ask you another problem. Hopefully you didn't have a chance to look at it yet. I'm asking you, again, a variation of the same problem, right? I'm adding more complications now. I'm basically saying the user is going to tell you the value, how many numbers, how many positive integers. So it could be 5, it could be 10. And then I'm saying instead of just printing the positive integer, I'm asking you to sum them up. So for example, if the user enters a value 4, instead of just printing 1, 2, 3, 4, I actually want you to print the sum of these numbers. So all I'm asking for is one output, which is the sum of these numbers. That's going to be 10. So I want 10. If the user enters 4, what I need to print out is, what the program needs to print out is 10. If the user enters 5, it'll be 15. If the user enters 6, it'll be 21, which is 1 plus 2 plus 3 plus 4 plus 5 plus 6. So think about what you need to change here to get from here to this. Again, this is incrementally building on what we've been doing so far, right? So think about what needs to change for you to go from printing the individual numbers to printing just a sum. Okay? All right. If you thought about it already, again, the clue here for you is I'm asking for the sum. So maybe in addition to a variable to keep track of the number of iterations, because I is helping you keep track of how many times the loop needs to run. But now, in addition to I, you also need another variable, right, to keep track of the sum. So maybe what you need to have is a variable name called sum, or maybe total, or something like that. And that's what you see me do here. Otherwise, again, the central logic is very similar. All I've changed here is I've introduced another variable called total. Again, I'm starting with, in this case, I'm starting with an initial value of 0 because initially total is 0. And then as the value of, I changes from 1 to 2 to 3 to 4, I'm basically adding it up. So first time the loop runs, i's value is 1. The total is going to be 0 plus 1 is 1, right? And then I increment the value of I by 1. I is 2. I'm adding 2 to total 1. So 1 plus 2 is 3. And when I is 3, I'm adding 3 to the total so far, and so on and so forth. So again, you can see how this works. So now the only change here that I made is basically adding another variable to keep track of the total, and then coming up with an appropriate computation, right, to compute the total as you go through the loop, multiple iterations. Okay, again, I want you to think about it. If you want, like you can just simply print the total like this. Let's say I'm going to ask the user for 4, right? Should be 10. I'm going to run the code again. I'm going to ask the user what should be the number. I say 5, should be 15. If I say, if I run the code again, if the user says 6, should be 21, right? So if you really want to see what actually is happening inside the loop, then uncomment this, right? And I'm going to run the loop. Just to keep it simple, I'm going to say 4. The total should come out to 10, but let's see what happened. The loop should run 4 times, right? So there should be 4 printouts inside the loop. Okay, so let's see. So you can see that first time the loop ran, I was 1, total was 1. Second time the loop ran, I is 2, total is 3. Third time the loop ran, I is 3, the total is 6. The fourth time the loop ran, I is 4, the total is 10. And then it checked for the value of I, and it was less, I became 5, and 5 is greater than what we wanted, 4. So it exits the loop, condition evaluates to false, exit the loop, and print the total. Right? But as I mentioned before, you don't really need the print statement here. You just need 10. If I say 4, I just need 10. But still, using the print statement inside this loop, it's good to see what's happening inside the loop. And this is a good way for you to think about troubleshooting, just to make sure that things are going as you planned. Okay, so again, what we've done here so far in the last couple of problems is basically take a core problem of writing a program to print positive integers and then kind of slowly added additional complexity. Okay, and we are doing this using repetition structure, specifically the while loop. Okay, so hopefully this is clear so far. Okay, and what I would like you to do is, actually, you can do 2 things. One, I would like you to now, instead of just saying sum of these numbers, right? Maybe think about sum of squares of these numbers. So maybe you can write a program to calculate 1 squared plus 2 squared plus 3 squared plus 4 squared. So that's one problem you can try to solve, fairly simple. Another problem you can try to do is this. Again, it's slightly more complicated. So you can try it, but if you don't get it, we'll go over this in class another time, right? So I'm basically saying the loop should stop when the sum is greater than 100. I'm not saying first 5 numbers, right? I'm saying start with 1, sum of squares of positive integers. Positive integers start with 1, right? And you keep computing the sum, and the loop should stop when the sum is greater than 100. The program should tell us how many numbers were used to calculate the sum. Okay, so that's while loop. Few other warnings before we stop, right? About the while loops is that, again, we've talked about this before. As I mentioned before, since the while loop depends on the condition you use in a while loop, you need to make sure that eventually the logical expression or Boolean expression you use inside the while loop changes to false so that the loop can stop. If it doesn't change, you'll have a problem at your hand, right? For example, I have something here, right? Same problem that we looked at. Let's say that we're computing the sum of the first n positive integers. But if I somehow forgot to include that I equal to I plus 1, right? If I don't have that in my code, if you never update it, then this loop is going to run again and again and again because i's value never changes. I's value is always 1, and 1 is going to be always less than or equal to, assuming the user entered, 2 or 3 or 4 or 5, 1 is going to be always less than num. Right? So this is going to keep running again and again and again, and you won't be able to do anything. You actually have to go up. You have to go up to the kernel menu and then you need to say interrupt kernel. So you need to actually interrupt the kernel to stop the program from running. Okay. So either you don't try this at home, or if you try it, make sure that you first, before you run it, make sure you figure out where the interrupt kernel is. Okay. So again, going back to the warnings here, so you need to make sure that one key thing you need to do is always ensure that you need to have something here to terminate the loop. Very important. Okay. All right. So again, if you want to try it at home, you can try it and then see what the total is, how long it ran before you could stop the program. Okay. Maybe fun thing for you to try it out. And then finally, once you finish this, once you're comfortable with this while loop, here are some practice problems. There are about 3 problems I have here. But the first 2, again, you should be able to easily solve. Okay, so read the problem and then solve the problems before you move on to the next part of repetition structure, which is count control loop. And we'll tackle this in a different video. Okay, thank you.